Ever wonder if an AI can learn the same way you do? Not by just memorizing a textbook, but by actually trying things, messing up, and then trying again? Well, that's the really cool idea at the heart of one of AI's most powerful fields, reinforcement learning. So let's break it down.
Okay, to get our heads around this, let's just forget about all the complex code and algorithms for a minute. Let's think about something way more familiar. In fact, you might even have one running around your house right now. Yep, we're going to talk about training a pet.
No, seriously, think about it. How do you actually teach a dog to sit? Or, I don't know, a cat to do pretty much anything you want it to? It all comes down to a super simple feedback loop. Your pet does the right thing, bam, it gets a reward. It learns really, really fast that that specific action leads to a good thing. And believe it or not, that simple loop of action, reward, and repetition, it isn't just for pets, it's the fundamental blueprint for how reinforcement learning works.
And here it is, the more formal definition. It's a kind of machine learning where an AI, we call it an agent, learns by doing stuff. It just tries things out, gets feedback like, good job, or nope, bad idea, and then it adjusts what it does next time. The key phrase here, the one to remember, is it learns from experience.
So how is this different from other types of AI you might have heard about? Well, with supervised learning, you basically give the AI an answer key. With unsupervised learning, it's just looking for patterns in data. But reinforcement learning, it's an active participant. It's not just studying, it's out there, in the world, learning from the consequences of its own actions. It learns by trial and error.
So, if this whole thing is a game, what are the pieces on the board? How does it actually work? Well, it turns out there are really only 3 essential parts to this whole puzzle. Let's take a look.
First up, you have the agent. This is our learner, our hero, our player. Just think of it like the main character in a video game that's playing all by itself. It's the one calling the shots and making all the decisions.
Second, you've got to have an environment. This is the world that the agent lives in. It's the sandbox it gets to play in. Sticking with our video game idea, this is the game level itself. The map, the bad guys, the obstacles, everything.
And third, and this is maybe the most important part of all, the reward. This is the feedback. It's what drives all the learning. You get plus 10 points for grabbing a coin, but you get minus 5 for falling into a pit. It's this simple system of carrots and sticks that's the only thing guiding the AI. And all of that brings us to the one single ultimate goal. The agent's entire reason for being is to figure out how to act in a way that gets it the highest possible score over time. That's it. Maximize the reward. Period.
Okay, so this is cool for video games, but it's not just for video games, not by a long shot. This is where the theory hits the road, and the results are, well, they're pretty incredible. Let's see how this is being used out there in the real world.
Just take self-driving cars. The car is the agent. The roads and traffic, that's the environment. It gets tiny little rewards for doing good things, like staying perfectly in its lane or braking smoothly. And then it gets the big jackpot reward for getting you to your destination safely. It literally learns how to be a good driver by practicing for millions of simulated miles.
Now I want you to look at this year, 2016, because this was the year that reinforcement learning had its major hello world moment. It did something that absolutely shocked experts all over the globe. I mean, this is the power of RL right here. DeepMind's AI, AlphaGo, didn't just beat the world's best player at the game of Go, a game that has more possible moves than there are atoms in the universe. No, the incredible part is how it learned. It taught itself. It just played millions and millions of games against itself, discovering strategies that human masters hadn't thought of in thousands of years. But, learning isn't always a straight line. The AI is constantly facing this big strategic dilemma that has a huge impact on how well it learns.
So that strategy it uses is called its policy. You can just think of the policy as the AI's playbook or its brain. It's the rulebook it follows to decide what to do in any situation. And the entire job of reinforcement learning is to keep tuning and improving that policy.
And here is that dilemma. At any given moment, does the agent exploit what it already knows? Stick to the moves that it's confident will get it a decent reward? Or does it explore? Does it try something totally new, totally random on the off chance that it might discover a secret, even bigger reward it never knew existed? Getting that balance right is the secret sauce.
And this brings us right up to today.
because reinforcement learning isn't just some concept in a lab anymore. It is one of the hottest areas in all of AI, and we're seeing new uses for it pop up all the time.
I mean, we're seeing it used to make the chatbots we talk to better, using a technique called RLHF, that's reinforcement learning from human feedback. It's how we're training robots in virtual worlds before they ever even touch a real object. It's mastering incredibly complex games and even optimizing huge, complicated supply chains for massive companies. The list just keeps growing.
So why is this so powerful? What's the big takeaway? It's because this is the closest we've ever come in artificial intelligence to copying the fundamental way that we and pretty much every animal learn. It's just practice, getting feedback from the world, and then trying to do a little bit better the next time. It's learning by doing.
And that brings us right back to our big opening question, but maybe with a bit of a twist. We started by asking if an AI can learn like a human, but now, after seeing how it can teach itself to master these incredible challenges, maybe the real question we should be asking is this: if an AI can truly learn from its own experience, what are the limits? What can't it learn?